All right, thank you for coming, everyone. I'm going to just start out, I'm going to introduce people who are here, are going to be part of the presentation and part of the project. And then I'll turn it over to the Deputy Mayor to open this up. But just to familiarize yourself with who's here, I'm Tony Mercantante, I'm the Township Administrator for Middletown. Fred Brody is part of the project team. Paul Haitman, Joe Blackwell, they are the sort of, we call them sort of the Lightus team, but they're the team putting together this feasibility study for the for this microgrid project. We also have Michael Hornsby here from the BPU, Dennis Blazak from the United States Navy, and I think that's everyone who's going to be presenting tonight. So we have a pretty good slide or PowerPoint presentation for them to go through, and I think hopefully you'll find it interesting and will raise a lot of questions. So what we're encouraging is you to ask questions you have tonight. We're also creating, and we have created, and you'll see this later on, a dedicated email address for anyone in the community who has questions that they might think of, another time where they couldn't make it tonight. You can send those into the to the email address, and we'll respond and share the questions with everyone. So, but right now I'll turn it over to Kevin Sanbrino, Deputy Mayor.
Thank you. Good evening, everyone, and thank you for coming tonight. Just to kick off what we're doing here this evening, and this is an exciting time for Middletown. This is a microgrid study. So, I want you to understand that in terms of a project, this is not a project. It is a study at this point. The Township of Middletown is one of 13 municipalities in the state of New Jersey to have been awarded a $150,000 grant from the BPU. Now, at this point, all the applicants, all the town applicants, did receive a grant. And what is this grant for? What is a microgrid, right? So we are in the midst now. This is one of many public information sessions. Okay, and we want to make sure that this is interactive. But what is a microgrid? What can it do? And how can it benefit the municipality? And the Navy is here as our partner here for this study, such that we can look at generating an additional energy source that can serve this region, and not all the town, but most of the town, and the critical infrastructure in the region. Okay, so this is a energy generator. Okay, it would be placed in the region. So the point of the study is to understand the options and what this can do, and it can take over for the grid when the grid fails in this area. Or similarly, it can add power to the grid. Okay? To understand what's happening this evening, we have our engineers here. The township got a $150,000 grant. Last year, we went out to RFP and hired Lightus Engineering to execute the study for us. We will present the study to BPU the end of this year, beginning of next year, somewhere around there. We'll get an understanding. We'll have many of these public information sessions. We want this to be interactive. We want to hear your questions. We want you to be a part of this. We want to make certain that this can be a benefit to Middletown and to the Navy and to the critical structures here in Middletown. So with that, I'll let the experts take over and give you some drilled in information about what we have here tonight. So, thank you.
Okay, thank you very much. Appreciate everyone attending, and as the Deputy Mayor said, we do want this to be interactive, so as we move through with the presentation, please don't hesitate to ask questions, because we want to make sure everyone's questions are answered. So, so as the Deputy Mayor said, this is going to be the rundown, very loosely on the time. We want to make sure that we hit all the high points. So, the Lightus team. Sorry, Mike. So the Lightus team, as the Deputy Mayor said, that we went through the RFP process, and Lightus is the lead company on this. Lightus is a very well-known and respected microgrid architecture company, $10 billion in total sales, which is $10.5 billion.
Yeah, a little more.
Around, something like that. And Paul, with his background, IEEE, as you see, involved with a lot of initiatives that we'll be able to talk about. I do business development consulting. I happen to be working on with Michael Baker Jr. company, a bridge building infrastructure company on the Oceanic Bridge. So I'm helping them a little bit with the public outreach on that, and involved with a lot of advocacy in the state And then, of course, Joe Blackwell is our lead with all of his experience and you know, technical knowledge on technology and regulation.
Right.
Okay, so at that point, Mike, thank you.
So, hi everybody, Mike Hornsby with the BPU. Here with my colleague Mike Winka also from the BPU, who's the mastermind, if you will, of the BPU program. So what I'm going to give you is just an overview of our program in microgrids generally, and tell you, like, Fred's not just making all this stuff up, but we, the state, think microgrids are a good idea. We have 13 projects like this going on around the state. So. Boilerplate disclaimer, we have a board, and all, official utterances come from them, not from we the staff. So I think all of us recognize these kind of images from Hurricane Sandy. We've all, Superstorm Sandy, we've all experienced this. So in the aftermath of that, what actions did the Board of Public Utilities take? Well, a couple of big ones. One, with respect to the grid itself, we took a number of measures, but more locally, we decided that instead of putting all of our energy eggs in these large baskets and then sending the energy to you over very long distances on wires mounted on wooden poles, that wasn't working very well during these storms. So we decided to go with a microgrid idea, and that is, putting your eggs in smaller baskets much closer to home. That's the kind of the essence of it. So here's a little quick illustration of a microgrid. If you think of JCP&L or PSE&Gs, their wires, that's the macro grid. So what we're attempting to design and build and plan is a microgrid, just a small kind of almost replica of that. So what this image shows is loads, that is our homes or buildings, but in the case of a microgrid, what we want to focus on is critical facilities, critical public facilities, police, fire, and in the case of Middletown, the Navy, places like that, senior housing, etc. So we want to connect all those together with a backbone wire connection, and connect both of the existing backup generators. Many facilities may have backup diesel generators. They could be a part of this, but in terms of adding new local energy sources, they'll be cleaner. It'll be solar. It'll be batteries. All those things will be a site-specific decision making. So we'll interconnect all those, so if one fails, we can rely on this multitude of different generation sources. So in effect, if the whole grid goes down, this small piece of critical facilities will be able to operate independently. That's the whole idea behind a microgrid. So in terms of just the definition, I've adapted this from the Department of Energy, and more or less what I just said. The loads are us, our demand for energy, and then the generators could be solar, existing diesel, batteries, or any other item that the project team identifies. So the grid can operate under so-called blue sky conditions on an everyday basis, but as importantly, under a dark sky condition, when the grid fails, the microgrid can break free in the island and operate independently. So the BPU, thanks primarily to Mike Winka, has taken a lot of initiatives with respect to microgrids. Right now there's about 58 of them around the state, and most of them are smaller and less complex. They're college campuses, things like that, even single buildings. So this notion of having town center microgrids is newer and different. We have NJIT helping us developing and identifying locations for these so-called town center microgrids. New Jersey Transit is building their own up in North Jersey, and that also provide limited service to several of the rail lines up in the New York City metro area. Mike authored a report in November of 2016 on microgrids. It's on our website here. And we're providing funding for these 13 town center microgrids. So Middletown is one of them. Here's the lineup of the towns and counties that have received monies from the BPU, average about 175,000, about 2.2 million in total. And here's their locations, and you're up here. So we kind of spread it around the state in the various service territories of our public electric utilities. So we have reporting requirements. So each of the applicants will be required to submit a report to us, containing a number of detailed elements. And what we expect next is we'll select a few of those to provide funding for a detailed design. So each of the applicants is working towards that goal.
So you all live near the Navy base, but you probably haven't come on board the base. So I'm going to tell you a little bit about what the mission is. So you can see here, we support the Atlantic Fleet. That is, we supply the Marines and naval aircraft of Fleet Forces Command. That's the part of the Navy that goes from here to the Persian Gulf. We're a strategic Navy asset, integral to the whole mission of the Navy and, of course, to the defense of the nation. So this is the Pier Complex. It's almost 3 miles long. This other wooden part that you see here, that's the old original 1943 pier. And then the steel and concrete pier that you see currently was built in the early 90s. The important part to remember, these are our ammunition ships, so we bring ammunition from the storage location back on Main side in Cold Snack, Howell, Tinton Falls, and Wall. We bring it down 2-lane road and railroad, Normandy Road, down to the end of the pier and load it on the ships. The reason it's called Normandy Road is because that's where most of the ammunition used by the Army and the Navy in the invasion of at Normandy, the liberation of France, and the final defeat of Nazi Germany came through your town. So this was a center for, obviously, the convoys would form up here, be protected by the Navy, go across through the U-boat wolf packs, and then reach England. So, and we have the same mission today, to move large amounts of ammunition very quickly and safely. All right, so we're a sizable asset. We cover a lot of ground. We split the county more or less in half. If we were a town, we'd be the 10th largest town in Monmouth County, but we're just a Navy base, so it's not the same. We only have about 1,000 people on a typical day, but we still do have a significant impact. The impact of the salaries, the contracts, and the other things that are actually spent right here just on the base came to about $120 million in 2016, but the overall effect of the Navy on the whole of New Jersey is much larger. There's contracts in many other places. Altogether, the Navy is somewhere around $2 billion to the economic, the GDP, if you will, of the state. But the important thing for you to take away is that Sandy affected us just like it affected all of you. So, during Superstorm Sandy, we lost a lot of trees. We actually spent about $1 million clearing trees from the railroad, from the buildings, from all the other places, opening up the patrol and fire roads. We were out of power for somewhere, depending on where you were, somewhere between 1 and 2 weeks. And we realized at that time that it was really necessary for us to adapt, that we should have some sort of resilient power. So we began doing adaptation steps on board the base, and we'll continue to do various things to adapt. The building that you see right here, it was only about 100 feet off the beach, but it had that's what V-zone damage, by the way, looks. Even though it was a brand new steel girder, concrete slab building, it was totally destroyed. So that's what V-zone looks like. We moved that building about 1,000 feet inland and about 8 feet higher for $3.2 million. So we're doing retreat as one of the adaptation steps, but we want to do a whole bunch of other things. Some of you might have heard about the oyster reef. So there's an oyster reef in place to the west of the Pier Complex, of that long pier. It's out about 1,800 feet, but the idea is that the oyster reef, as it grows, it'll have ecological benefits. You know, it'll clean the water, it provides fish habitat. But from our point of view, it'll mean that the waves break during a nor'easter out in the bay rather than on the beach itself. So it'll reduce the size of the V zone and reduce the damage of flooding to the interior, to the Route 36 storm evacuation route, and also to the base itself. The thing that I want you to remember, the thing that I'd like you to take away from this, is that although the Navy will adapt to storms, we're planning our buildings that they'll last for 70 years, and we're anticipating what water levels and storms will be like 70 years from now. If we're the only ones that do it, we'll end up being just islands in the stream. We need the community to also participate and coordinate. Our goal is to be able to withstand a 1,000-year storm and continue to do the mission of the base, just as the Atlantic Fleet will have to do its mission.
Okay, we're going to be moving along to a little bit more of a technical presentation, and will everyone get a charge out of this? But
Measure the voltage at the end of my car.
But no, so Paul is going to get into the technical aspects a little bit more, and basically, if Mike didn't mention it, these studies involve like three aspects: the economic model, the technology model, and the regulatory model, or what's going to come out of that with recommendations in all three areas. So Paul's going to get a little bit technical here and read through that, and I'll get out of your way.
Okay, thanks, Fred. So from a standpoint of a little bit of reinforcing what the microgrid is, the picture's always worth 1,000 words, and you can think of it as energy resources, but somebody asked the question, what does DER stand for, distributed energy resources? Actually, over in Europe, where they've deployed a lot of solar and a lot of wind and really distributed energy resources, they're actually moving the language to say distribution flexibility resources. So not just energy production, but the ability to sensibly balance and coordinate all that. So it's kind of a semantic, but it's an interesting shift, distribution flexibility resources. So the idea is having things at the edge of the grid here that can work in harmony with the utility are good. And when you put enough of these together, you can create a logical aggregation, which is the equivalent of a power plant. They're calling virtual power plants because they're virtually one big plant, but these are distributed resources that can be connected and used as an integrated resource. No, go ahead. Next. So I'm involved, part of my job, I'm involved in the standards side. IEEE is the Institute for Electrical and Electronics Engineers, and they have a standard, this is just revised actually, for what's called interconnection. So you can notice in these grid connections, you've got an interconnection to the grid. This is something that the BPU has authorized that the utilities require if you want to connect energy resources into a live grid. That's the foundation of putting a variety of things, not a nuclear plant, but some of these smaller edge resources and allowing them to interoperate. And there's a series of standards that are developing not for interconnection, but for interoperability. And these relate to how different things work within those clusters or those microgrids. So electric vehicles, battery storage, energy management systems that coordinate building load and orchestrate that. And then there's even a standard for a microgrid that was just released, which is 2030.7. So there's a lot of standards that are coming that are enabling this. So another picture, I know there's a lot of different pictures of a grid, but if you just go to the next slide. No, that's okay. What's happening is as these things are becoming interconnected and coordinated, you're opening up use cases of how you use these. One of which is the one we're doing here is a community microgrid. Now in some community microgrids, they're actually power sharing within the microgrid. So production happens on one house, consumption, or even offering storage resources that coordinate with that, and it's resolved at the community before it even nets out and connects with the utility. So I'm describing how other states, other parts of the world are actually implementing these technologies. Another big one is electric mobility, and that is definitely coming to New Jersey. In fact, I've got my charge EVC pin. Mike Hornsby's a big advocate on electric transportation. This is a coalition that's formed to help set policy in New Jersey for adopting electric vehicles and integrating them with the grid. And then the third one is really something that is a little more advanced, but where all of this is heading. And that is a utility, which is now known as a utility selling energy to you in one direction, in many states is evolving into what's called a distribution system operator, where it's a little subtle, a little semantic, but it's allowing services to exist and these edge assets to participate as a service for the grid to balance and coordinate and meet their reliability goals. So really, at the end state of all this evolution, you've got a very integrated, holistic, what I call participative energy, where a distribution system operator can use these resources. So, yeah, next one. So what are they? Now, Joe's got a slide that has some bigger pictures of the individual things, but we wanted to show examples, because the reason I put the silhouette of the nuclear plant, everybody thinks, oh, that's a huge power plant, and they are, you know, the billowing steam and all that. But when you move down to these distributed energy resources, they're very compact and efficient and producing energy, but they don't have huge footprints. So there's examples of, you know, fuel cells are one. We may see some of this offshore, actually, coming for wind generation. And we're going to see batteries in everything from small ones on the side of a residence to banks of batteries that are integrated and clustered. And I think, was it Mike, you mentioned even diesel generation, or somebody mentioned even
Well,
diesel.
existing diesel.
Yeah, existing diesel generation could be included because it's a resilient resource that can be used. And then that interconnection here is governed by that standard. And even on the load side, with the lights and the motors and the TV screens that are, what's happening is there's a lot of technology evolution that are allowing, for example, you might have heard Internet of Things, this whole thing of sensors that are very low cost. You can measure how things are operating and feed that into a system and use that for balancing. Of course, rural wireless technology, there's 5G coming, energy storage. Even some of the power electronics are able to switch a lot of power quickly, leading to what's called the energy internet. That's a trend that's coming. We all know what the regular internet is with switching data. Switching power is coming too with some of this material science development. I won't go over this in great detail, but this is the grid in its entirety. So if you think traditionally all of the generation that's done far off from Middletown, it's done through decreasing amounts of coal, increasing amounts of natural gas. Of course, nuclear is the big question mark in New Jersey and other states. We don't have much hydropower. We will have some wind. But this represents central generation that needs to be pushed through wires from far distances onto the distribution network, this would be the JCP&L, and then delivering to what's called the edge of the grid. And this is where the innovation is happening, where a microgrid would make sense to group these resources and have them coordinate at the edge of the grid, and in conjunction with electric vehicles and efficiency and some of this other smart, intelligent load management. So that's the general move, why these elements here are becoming very powerful, and we need to design the right way to handle them and absorb them. Microgrids are an important way to do that. And as Fred mentioned, our feasibility study really breaks down to the feasibility of, this is the technology assessment. So these are examples of fundamental technologies that are allowing microgrids to exist and changing the way the grid operates and how the utility company can move into a distribution system operator. And there's three aspects. One, from a technical standpoint, what are these technology components? Sort of where are they on their evolution path? Are they emerging? Are some of them obsolete? That was the interoperability standards. How well do these work together to do that kind of operation? What standards are there? And then where we can, we'll put some examples of references of this is being used in these examples, both in other states and worldwide. And Lightus has some pretty strong experience, and there are some existing projects that we can use as reference on the technical side. Financially, the easy way to say is, well, what are the current costs of these? how expensive are batteries and where's the cost going on batteries. But really, that has to be balanced. How long will they operate? What's their duty cycle of how they operate? And this is a very important one that we need to look at. What's this going to do to the existing electric grid? There's a lot of investment already, and more, coming, about existing capital that's been put in. If we invest in this instead, or if it disrupts that, or makes it obsolete, that's an impact. So that's part of the financial impact, and ideally, we're going to look at the net system cost benefits, either net positive or net negative, against these technology components. And then lastly, barriers to adoption on the regulatory side. That's essentially what this whole program is about, is to have 13 people do feasibilities, report back to the BPU, and that will be assessed and analyzed and inform policy changes that the commissioners will look at doing. As Mike said in his disclaimer, we are not making the policies, but we're informing the policymakers, and this will feed into that process. So here's right down to home now, what we're dealing with here. This represents all of the elements that were identified as participating sites, and this graphically represents sort of summary of a year's energy use in megawatt hours. And this one and this one that are really standing out, those are the high schools, north and south. So that's a pretty energy dense place, right, that uses a lot of energy. It's also a pretty critical location that could be used in a recovery, emergency recovery, for staging and a variety of uses for disaster recovery. And what we're talking about is, and I probably put this at the wrong, where's Dennis? Is that approximately right?
It's on the water.
It's on the water, right? I knew that
You
much.
couldn't either confirm or deny
I
that.
can't.
If he does, he's gotta kill.
Right, that's right. But you can see that the kind of technologies that I talked about, we're looking at placing there and then feeding these critical loads that are within one or maybe two. That's another option. These are all kind of options we're looking at. So this is a possible microgrid configuration. I took the more complex one to just show you that, let's just say this is Middletown North microgrid and this is Middletown South. For some reason that makes sense. Then the idea of microgrids that are adjacent, that are coordinating and communicating, that's where a JCP&L service connection that runs on their wires, that can't be done now, that's regulatory barriers, but it might make sense. This could be a way that we could say, allowing this would increase the resilience by perhaps, putting some critical load here that could be separately managed from this section, and they could be balanced together. So we're not saying this is a configuration. I'm using this just as food for thought about where this might go. And of course, the generation could be hosted at Earl in various forms. Just quickly, I think some of the people in the room here had seen this survey. This is how we started the whole process. We really asked for an assessment from these participating locations, really looking at how they used energy existing, how they consumed energy in existing past 3 years. Also, do they have any plans for distributed energy, even if it's a diesel generator or had one already? And then identifying any mission critical load, which is part of their operations at school. Obviously, the classroom's mission critical, fire station is the main building, etc. So it's important. So really, this was to characterize the use of the site already and the energy load and density and everything. And we've had kind of a mixed result on that. It's been pretty hard to get the energy data. We're trying. There's some barriers there. That's going to obviously be in our findings. And we're already looking for ways to improve that and get the flow of that going. And by the way, that is a big national trend in many states. There are New York, for example, California, others have actually moved for freeing up the data that's at the edge of the grid that is very hard to coordinate and get through legislative and policy changes. So that might be something that comes to New Jersey as well. And I think that's all I had. So that was like Electric Grid 101 from big to little. So yeah. No, it has a lot of great potential positive, And part of kind of logical next steps that happen from all this are many other states are and parts of the world are actually forming what are called regulatory sandboxes. They're saying, you know what? Let's try this piece here. This is an ideal one because it's next to a naval base. It's like, you know, community next to a DoD facility. There's a lot of really positive things. But there are some barriers right now. Maybe we rope that off and say, for the next year or two, we build this, we try this out, we look at ways for existing regulations to be, you know, there's methods for that. But it definitely has to go through the, you know, process with the.
So this is just a quick introduction to Lightus, because I'm not sure anybody or anybody's heard of Lightus, but we're actually one of the biggest government services and engineering contractors, if you count everything from federal down to municipal level, in the U.S. So we've got focuses on defense and intelligence systems and support. We've got healthcare, administrative support and systems. We've got an advanced solutions development organization that's really looking at, you know, cutting edge technologies and cutting edge applications. Down here in the civil group, we're focused more on critical infrastructure, and that's where my organization resides. I'm in commercial energy solutions. These are examples of the types of services and capabilities that we provide to our utility and energy-oriented clients. But what we also, being a part of such a large organization, is we also have the ability to tap into what's called our technical core competencies. So we've got company-wide efforts on everything from program management, you know, basics to to system integration to cutting-edge systems like blockchain and some of the things that Paul was sharing. So we have the ability
and financing solutions.
and financing solutions, yeah.
A very important part. How do you?
So we bring that to this mix as a set of resources to help hopefully arrive at the right answers for this study. Just by way of example, these are four examples of microgrid studies we've done in the past probably 4 or 5 years-ish or so. Everything from demonstration projects for the Department of Energy to some work for a military base, for critical infrastructure on a military base. That was commissioned by the DOE and the Pacific Northwest Lab. A food processing sort of campus microgrid in Fresno. That's where I come from, is California. It's a big farming town, so their focus was on resiliency in the food industry. And Hawaii, where arguably they've got some of the most progressive distributed energy policies in the country, and some of the biggest challenges too, because every island is a world unto itself. We do quite a bit of work for them, but one of the studies we've done for them from a microgrid perspective was designed to defer some pretty serious capital investments in terms of wires and typical utility infrastructure. So those are the type of things we do. I think Mike shared pretty good background on the purpose for this study, and what I really want to do here is just kind of share this. From a chartering perspective, this is how we take our mission to be here, along with everything else that's been shared. And this will be up for you all to read when you're ready. Paul mentioned looking at some examples of typical kinds of microgrid infrastructure. I know the conversation about rooftop solar came up a few minutes ago. That is a picture from Brooklyn over here in the upper left. So there's in New York, right across the way there, they're actually doing sort of a energy sharing solar initiative in a neighborhood setting. This is an example of what typical large-scale battery storage systems might look like, and the appearance and the size of these can vary widely depending on the technical requirements. But we're not talking about hugely intrusive options in that space. A generation unit like you see down here, a gas heat and power unit would probably be something that would be sited outside of a neighborhood if it was required, if that was part of what the study called for in terms of capacity. We might be looking at potentially, whether it's Earl or someplace else, placing something like that. And these are, I see a lot of these in California. The parking lot covered solar solar. That's almost like commonplace now, it seems. But there are a lot of ways to place generation capacity in non-intrusive and attractive ways. This is the one ugly example. That's control system gear and maybe some storage there. That could be, if anything looked remotely like that, it could be sited unobtrusively, or potentially, some of that could potentially be put on a rooftop or the like. So the goal here, I think, as much as anything else from a community interest perspective, is to make it as non-intrusive and impactful as possible, certainly. You've seen that picture. This is a list of the critical infrastructure locations that are within the scope of our study. So you can see we've got sewage facilities, we've got Earl, we've got ferries, we've got schools, and a number of municipal buildings, fire, and the like, as well as some critical traffic management systems that will help provide for access and continued operation in the case of a large-scale interruption. Are our partners on this project. Really, we kind of view, as well as I think what we would say is, you as a community are also partners on this, and that, we'll talk about that in a second here, but we certainly want to, this dialogue and this interaction here is valuable for us in terms of conducting the study, and we're anxious to continue that throughout the course of the next several months while we're at work on this. This should line up pretty closely to the requirements that Mike outlined.
One would hope.
Yeah, one would hope, yeah. This is a distillation of a much larger table of contents, but these are the key elements. You'll see the financial, the technical, the regulatory pieces are in here. Ultimately, like everybody said probably 4 or 5 times, our job is to make recommendations. We're not setting policy. We're just going to provide data and information and analysis, and ultimately hopefully some support for the folks who have to make the policy decisions. A very simple picture of the project schedule. So we're essentially in the data gathering phase right now. I think Paul mentioned it's taking a little longer than we expected, but we're in process there. This is our first outreach, so that's where we are today. We're going to be conducting the technology, the code research, and some of the other activities that were also mentioned. That's actually underway right now. Ultimately, though, on the Lightus side, we've got a team of distribution systems engineers, distributed energy resource experts, who are going to, as well as economic experts, who are going to conduct the analysis along with Paul to support the outcomes of the study and ultimately make the recommendations. So our hope is that by September, if this timeline holds together, at our next meeting, we'll be able to share some insights about what we found, what our maybe not finalized recommendations, but at least after this dialogue and this foundation setting, we'll be able to share a little bit more detail and have a more specific conversation than we're having today. And ultimately, the final report, aiming at the end of the year. I think November's our goal to get that done and delivered, and then it'll be in the hands of the BPU with the rest of the study findings. There's an email address that's been set up, and this, you can write it down here. We can leave this up on the screen actually for you if you want to write it down. But it'll also, as I mentioned, this presentation will be posted, and you'll be able to go to this and review it again. But certainly we encourage you at any point in time to ask questions, provide comments, concerns. We'll try and answer everything. We certainly will consider everything that we receive. It'll be a moderated email site, and it'll be passed across the project team, so we'll all see it and hopefully have a chance to get it to the right person to help answer any questions that come up. We want to hear from you during this process. So if you become aware of something that you've heard from other study efforts, or just from as you become more familiar with the technology and the issues surrounding this, please feel free to bring them forward, because I think that's certainly the BPU cares, and we want to make sure we can incorporate that into the study findings.
Good.
And that is, I think that's it.
Any more questions?
The Navy changed some of the things that it did to talk to some of your points. We had a group that was called the Renewable Energy Program Office, and they were really focused on trying to install 1 gigawatt of renewable alternate energy, and it was all over the world, which they already did. But then the name of the group was changed to the Resilient Energy Office. The idea being that what we really needed was power that would stay on no matter what happened to the grid.
Yeah.
That when everything else goes dark sky, we can still do what we have to do. We're really very, very focused on being able to keep on doing the mission, to not have mission failure, to be able to continuously support people all over the world. In a few weeks, the commander here, our public works officer, is going back over to the Middle East. If you notice, he has a lot of really colorful ribbons, and he didn't get them for flying a desk in New Jersey. He got them in horrible, terrible places in the various wars that we ask our people to go to. And the point is that the community here in Middletown is part of that effort. They're part of allowing the base to continuously do its mission to be sustainable for the long period. This is really, it's very important that we work with the community, because if you don't become resilient too, then our people can't get to work, our utilities will fail. Even though we'll do everything we can, we'll be jury rigging our operation, and that's not effective. Yes.
I think the whole thing is tremendous. I know we came in asking a lot of very specific questions, but I'm excited to be in a town that pursued this feasibility grant, and I think it's very exciting to think about the future and the potential that this could allow for our area. Again, not just for the public entities that you've defined, but also the potential for private to get tied into it in the future. So back to kind of the JCP&L distribution network, to the extent that this is in any way reliant on that, my concern is, given JCP&L's kind of recent track record and the current state of their distribution network relative to the other utilities in New Jersey, I'm concerned that our application, our chances of getting to the next step are actually hindered because we're in JCP&L territory. No?
No, the idea is, so if JCP&L goes down, the system will island. It's designed to do that.
Okay, so there's, from an infrastructure standpoint, we are not on their wires at all. So if a distribution pole goes down, everything would be, I know that Dennis talked about the Earl, the Navy Road, et cetera, being used for an underground line, but where it needs to, separate out from that, it would all be independently managed lines?
Well, as several of us said, the microgrids will operate during a blue sky condition and during dark sky condition. When the grid is up and when the grid is down, that's the whole point of a microgrid. That's
Okay.
why we're here.
Great.
But really, most importantly, we want to thank Middletown Township, Earl,
Yeah.
and especially our friends at the BPU for coming. So we're going to keep this rolling. And thank you.